Hello! I'm going to go over how to complete the practice problems for momentum. This is good. Reviewing this video will be good preparation for the quiz that we have tomorrow. Tomorrow being Wednesday, February 22nd. On this quiz, I'm going to ask you primarily how to solve questions like the ones that you'll see on the first couple of pages of your practice problem sheet. Alright, let's go over some of these. So for each collision below, fill in the missing momentums. Whenever solving any of these problems, what you want to do is just say, what is the total here? What is the total after? We know that they have to be exactly the same. So the total here is 100 plus 0. We know that afterwards the total also has to be 100 kilogram meters per second, or roys. If this is 0, then this also has to be 100. So for those of you that were working on the penny station, that's the collision right here is exactly like what happened in the penny. One penny hit another penny, and then the other penny shot off with that same momentum that that first penny had. Alright, let's keep moving. So total here would be... we don't know yet. Okay, well, let's go back over here. Okay, so over here it says the total is 100, I'm going to say roys, to the right. And that means if it's... oh no, math mistake, 200 roys to the right. If it's 200 roys to the right, then here it also has to be 200 roys. Right. Then if this is 150, then that has to be 50 roys. 50 kilogram meters per second. Alright. Now, on to the ones below. Remember, the totals have to match up. Total here, we don't know it yet, but total here. Okay, the total here is 0 roys. The total here also has to be 0 roys. If this is 50 kilogram meters per second to the right, then this has to be 50 roys left. And remember, roys and kilogram meters per second are interchangeable. It really doesn't matter which one you use. Okay. Let's keep working. Alright, in number 6, what is the velocity of the white marble after the collision? I have to do the same thing, but I have to figure out the momentum first. Alright, so here it's 5, remember, P is equal to M times V. Oh, it looks like my marker's about to die. So P is equal to M times V. Here, P is equal to 25 roys. Here is equal to 0 roys. Mass times velocity of 0. We know the total has to be 25 here as well. If this is 5 roys, then this has to be 20 roys, because we know that 25 has to be equal to 25 right over here. So if this is 20 and that's 4, then velocity is equal to 5 meters per second. Number 6, what is the velocity of the white marble after the collision? We just solved this. V is equal to 5 meters per second to the right. Okay. Before, 6 kilograms times 5 meters per second, that's 30 roys. This is negative 8 roys. So the total has to be 22 roys. Why is it negative? Because this is negative right over here, this 2. So here, if it's total of 22 roys, and if this is 16 roys, and this has to be 6 roys. That means that if this is 6, mass times velocity, this guy has to be 1 meter per second. P is equal to M times V. Moving on, here when the blocks collide, they stick together and then travel together, okay? So before, 25 meters per second, that
is 100 roys. If this is at rest, then V is equal to 0. That means that M times V is going to be 0 roys. Sum of these two is 100. That has to be 100 as well. Now, if the momentum is 100 and the mass here is 5, because it's 4 plus 1, then V has to be 20. 5 times 20 is 100, so V is equal to 20 meters per second. Right.
I'm going to go over this problem, and I'm not going to go over any of the extension problems just yet. Oh, and I'll go over the car problem. I won't go over the extensions yet, though. Okay. Gray marble and a white marble are going to collide. The gray marble 2 kg is moving at 100 meters per second to the right. The white marble 4 kg is also moving to the right, but at 10 meters per second. Ooh, okay. So calculate the momentum of the gray marble. Here's gray. So gray is, remember, P is equal to M times V. M is 2, V is 100, so let's say 200 rois right. White marble is 40 rois right. 200 is bigger than 40. Gray marble has more momentum. The total momentum of the system before the collision is just this plus this. So, and because they're both in the same direction, we can just add them. 240 rois right. The marbles not collide. Using the law of conservation of momentum, what is the total momentum of the system after the collision? It has to be whatever it was before the collision. Before and after, they have to be the same thing. So if it was 240 rois before, it has to be 240 rois after. After the collision, the gray marble has a final momentum of 120 kilogram per meter second right. What is the final momentum of the white marble? Well, if the gray marble is moving at 120 kilogram meters per second, we know that it has to add up with that white marble to be 240. So if this is P1, we know that the other one has to be P2, has to be equal to 240. This one also has to be 120, right? So 240. Oops. Final momentum of the white marble has to be the same, 120 kilogram meters per second, right? Using the final momentum for the white marble that you calculated in part E, so that's over here. What is the final velocity of the white marble? So if it's 240 rois right, and the mass of the white marble, P is equal to 240 rois, mass of the white marble is 4 kg, then V is equal to P over M, which is equal to 240 rois over 4 kg, which is equal to 60 meters per second right. Oh. 60 meters per second to the right. Got that trap music going in the back. Oh, I'm so cool. Anyway, and this is the last question I'm going to go over for your quiz. Alright, team of physics students decide to make a monster truck and a small car to smash into each other head-on to see what happens. They're remote controlled, so no one will get hurt during the physics problem. Yay for safety! Okay. So we have a mass of the car is 85 kilograms, and a velocity of this car is 80 meters per second. The mass of the big car is 200 kilograms, and the velocity of this car is 34 meters per second. They're going in the opposite direction, so they're going to collide, and then something's going to happen. They might either stick, one might overpower the other, and then, or one might overpower the other, right? So we don't know. Let's do some math to figure this out. Calculate the momentum of the small car before the collision. Okay, small car, P is equal to M times V. In this case, the mass of the small car is 85 kilograms, and V of that car is 80 meters per second. That means that
the momentum of the car should be around 6,800 rois. $6,800 right. Alright, calculate the momentum of the monster truck. Let's see. So P is equal to M times V. The mass in this case is 200 kilograms. The speed is 34 meters per second. That means that the momentum also has to be, I think, the same number actually. So 6,800 rois, but this time it's moving to the left. The total momentum of the system after the collision has to be the same as it is before. And before, if both of them are going against each other, then this would be positive and this would be negative. This would be positive, that would be negative. The total momentum before has to be 0. Otherwise, if they stick together, what will their final velocity? V final is equal to 0 meters per second. So this is P final. This is momentum final.
Alright. Physics team decides to do this experiment again. This time they put a 35 kilogram sack of rocks in the driver's seat of the small car. The small car has the same speed as it did in the first test. Calculate the momentum of the small car before the collision. Okay, so P, the small car, is now well, it's still m times v, but now m is just 85 plus 35. It's the mass of that small car plus the bag of rocks. So that would mean that the mass is 120 kilograms times whatever the same speed it had in that first test, which is 80 meters per second. So we know that the mass is 120 kilograms, the speed is 80 meters per second, so we end up with a momentum of 9,600 rois, still in the same direction to the right. The momentum of the truck was the same as it was in the first experiment. What is the total momentum before the collision, after the collision? Okay, so if the car now has a momentum of 9,600 to the right, and we know this truck has a momentum of 6,800 rois to the left, the total momentum is just whatever's going to the right minus whatever's going to the left. So we have 9,600 minus 6,800. Which direction?
Is bigger, left or right? You can see that left is going to be larger, so we're going to have 2,800 rois to the right. Sorry, the one coming from the left is bigger, so it's right. Okay? These are all of the questions that you guys are going to have, that you guys could potentially have on your quiz tomorrow. Feel free to email me, send me a text, send a remind message, whatever you need to do if you have any questions about any of these solutions, okay? Have a great day. I will see you all tomorrow.